Hello, I'm David Gowans, Managing Director of Drill Corp, a Northeast-based company specializing in borehole engineering for sustainable water and energy systems. Today, I'd like to share the story of how we're helping to breathe new life into the UK's former coalfields through the power of MineSource. MineSource is a renewable energy solution using warm water from abandoned mine workings to heat buildings. Boreholes are constructed to extract this water, passing it through a heat pump before returning it back into the mine through another borehole, creating a closed-circuit, zero-waste loop. Drilling into old mines isn't a simple, straightforward task. You're aiming for seams that can be just 4 meters wide and sometimes 600 meters deep. During drilling, you might find collapsed tunnels, mine gas, lost drilling flush, or even century-old rail tracks. There are a lot of potential challenges to consider before even starting a MineSource project. In Gateshead, we supported one of Europe's largest MineSource systems. The biggest challenge for this project was aiming for target mine workings that were over a century old, combined with unreliable mine records. For this project, we suggested an exploration phase before we started the full production. It's the careful planning that can save time and money in the long run, avoiding issues during the construction phase. It took 12 exploration boreholes to locate suitable abstraction sites, but we found the right locations, tested them and converted them into permanent wells, and it's now a thriving energy system. At Lanchester Wines, the challenge we found was that the previously drilled reinjection boreholes were clogged with iron deposits. To tackle this issue, we used our state-of-the-art bore restore unit. This is a high-pressure impulse jetting tool. We cleaned deep into the fractures and restored the flow. Part of our remit was to construct a brand new abstraction borehole without disrupting site operations. This project required an exploration phase to locate the optimum site for the production borehole. The exploration phase consisted of 6 boreholes drilled to 260 meters below ground level to find a suitable production site. The new production borehole, once constructed and developed, far exceeded the yield of other production boreholes on the project. In Blaydon, the borehole location was tricky, in a car park, next to a slope and above a protected lake. The mine water was also artesian with an expected 10-meter head. For this project, we planned meticulously to prevent spills. Our articulated Combi 300 rig and custom wellhead control system made sure not a single drop of mine water escaped to ensure a successful operation. Recent test pumping operations have proven that the system will be ideal for the ground source heat pump to deliver warm water to the Health and Leisure Centre. At the Glasgow Observatory, which is part of the UK Geoenergy Observatories project, our task was to drill into deep mine workings for advanced thermal monitoring using sophisticated sensors. This site posed complex geological and technical challenges. The target workings sat beneath multiple worked seams, all of which were open. Maintaining borehole alignment while avoiding collapse or contamination required surgical precision. We used reverse circulation drilling techniques to penetrate the strata safely and construct the system to the technical design. We collaborated closely with the sensor manufacturers to protect and correctly install the monitoring equipment. The project was a huge success. The Gateshead Living Laboratory was a really exciting project. The only site in the world where you can study how multiple mine water heat schemes interact with each other underground. We were contracted to construct 4 scientific boreholes that passed through multiple worked coal seams before reaching the target seam. The real challenge was sealing off the upper seams to make sure the monitoring equipment only captured data from the correct level. We initially tried a specialist grout, but this ran straight into the old mine voids. So our engineering team designed a mechanical sealing system, a completely new approach, and it worked perfectly. Once sealed, we installed very delicate monitoring instruments, which had to be placed with absolute care. Having gained experience on the Glasgow Observatory, we were confident in handling that level of precision. The project was a complete success and continues to produce valuable data. Every site is different. But what stays the same is our commitment to safety, precision and client collaboration. We work closely with partners from consultation to execution, ensuring reliable long-term solutions. We're proud to be leading the charge in mine source development, proving that innovation and heritage can go hand in hand.